Welcome engineers, ladies and gentlemen. My name is Dele from DevOps and Cut. Today, I'll be showing you a very, very important tool in the DevOps tool chain. This is called SonarQube, and I will show you how to install, configure, and deploy SonarQube on an EC2 instance in the AWS cloud. Now, in case you're wondering what SonarQube is an open source and platform used by software developers and quality assurance teams to ensure the quality of code. SonarQube helps us to check our code for bugs, vulnerabilities, track code smells, technical debt, and even helps us to eliminate or minimize code duplication. So today, our task is as follows. We shall set up a SonarQube server on an EC2 instance and access this SonarQube server from our web browser. We shall containerize it as a Docker application. So we shall containerize SonarQube and access it from the browser. That's the task for today. So the first thing, we shall have launch an EC2, install Docker and Docker Compose on the EC2 instance. Next, we shall write and configure a Docker Compose file. We shall call it dockercompose.yaml. It's a YAML file. And then we shall run a Docker Compose file. So we can run our containers, first for SonarQube and for PostgreSQL, which is going to be the backend database for our SonarQube. After that, we shall access our SonarQube server from the browser using our server's public IP address on port 9000, which is the default SonarQube port 9000. Okay, so we shall do this, spin up EC2, install Docker Compose, create a Docker Compose file, run it, and access it. So now let's go to EC2 and create our instance. Okay, so we shall create our EC2 instance, which will be our SonarQube server. So there, let's launch an instance. Let's hold on, it's a bit slow. Okay, so we shall call it, it'll be my SonarQube server. It could be any name really, but I like to use meaningful names. Since it's going to be a SonarQube server, let's just call it that. My SonarQube server. After we name it, we shall select an AMI, that's Amazon Machine Image. We're going for Ubuntu 22.04. Ubuntu. You have choices, but I'll use Ubuntu in this case. So Ubuntu is the Ubuntu server, which is SSD volume type, solid state drive. We'll select that. It's on the free tier, which is what I'm using it, so it wouldn't cost you anything if you don't go beyond it. Okay, now the instance type, I would select a T2 medium because we need at least 2 CPU and 4 GB memory. So something slightly bigger. This will cost you a little bit, so you need to make sure you destroy as soon as you finish this project. So T2 medium, you see it's got 2 CPU and 4 GB memory. That should do for this project we're doing. We need a key pair because we shall need the key pair SSH into our instance to do the installation. So for the key pair, let's create a new one. Call it something we can recognize. Maybe a SonarQube key or Sonar key. Hold on, let me see. Let's do Sonar key. Okay, so we know that's for SonarQube. We'll leave it as RSA key pair type. It's a PEM file, so let's leave PEM selected. And let us create our key pair. When we do this, it automatically will download the private key onto our local machine. So we shall use this on the command line to SSH to connect to our remote server, which is our SonarQube server, our EC2 server we created here. So now security group, which is like a firewall, we need to allow SSH, since we're going to use that to connect remotely. Also web traffic, so let's do 80, port 80 HTTP access, and also we need to allow the SonarQube server. So let's do add one more for the SonarQube server. Excuse me, I've got a slight cough. Sorry about that. The SonarQube server, that comes next. So let's name the security group something we can remember. So SonarQube SG, just security group. Describe it, same name, SonarQube SG. So we need, for our firewall, we need to allow inbound SSH, that's port 22, HTTP, that's from the web traffic, port 80, and SonarQube. SonarQube default port is port 9000. I will use 990 intentionally just to show you how important the firewall is. So we shall put in the wrong port for SonarQube just to show you how important it is to get the port correctly. So instead of 9000 here, I have us put 9090 just so you can understand this better. Now open to the public 0.0.0/0 everywhere, since it's going to be from the browser, internet. So that's all for the security group. For our storage volume, let's make it 20. Just have enough. Let's have extra storage volume. Let's just 20. We have up to 30 free of charge. Let's just do 20 here. That's all. Okay. We can leave everything else as default. So we've named our instance. We've gone for the Ubuntu AMI. We've created a key pair. The security group, we've opened port 22, 80, and 1990. It should be 9000, but we did 1990 for SonarQube just so that it will fail and we can see the importance of getting the port right. Okay, that's all for this. Okay, everything looks good except Sonar port, but let's leave it as that. Okay, yes, 20 GB. Okay, let's launch the instance. Let's launch this now. Okay, we launch the instance and our EC2 server is getting ready. It's been created, after which we shall log into it through SSH and install Docker Compose, and we shall run commands to run our containers in the instance. Okay, now there it is. Our server is pending. Let's refresh to see if it's running. I'll refresh. Yes, now it's running. Our server is up and running, which is beautiful. That's it there, the top one. Yes, so now it's running. What we need to do is we need to grab our server's public key, and then we can do the SSH on the command line, and we can log into our instance and start the installation. So there, let's grab that SSH there, and we shall head on to our command line, and there we shall run that command, which will, now to run this command you have to be in the directory where your private key is from the key pair. So I'll just use this Linux command. I'll navigate into my download folder, which is where it is. So // means 2 steps up to go to the main folder daily, and then CD to download. So you see I'm in my downloads folder, and now I can run this and it will find my private key. So let's go, hit this. Yes, let's select yes. Want to continue, connect. Yes, want to connect. Yes, there we are. Ubuntu, you can see the there we are in our instance. We're inside our instance. There, right in. So now we have to do things. We need to update apt package. We shall upgrade it, and then we shall install Docker. So I have already put the commands we need to just copy and run here. So let's do sudo apt update. That should update the package registry. So let's run this first of all. So sudo apt update, and that's going to help us update the registry. After that, we shall upgrade. We want to have the latest versions of everything. So after this, we shall run sudo apt upgrade with the -y option. What this does with -y is that it will bypass the prompt to select yes or no. It will just go through, so it's much quicker if we know what we're doing. So the apt upgrade -y. Let's paste that and run it. Now we're upgrading the existing packages to the latest versions. Okay, so far we've created an instance. We've logged into it. We've updated the package registry, and now we're upgrading the existing packages. When this completes, we shall now proceed to install Docker. We need Docker to run commands. We need Docker because we're going to create a SonarQube as a container. Okay, it'll be a container. We're going to run as a container. So we shall install Docker, and then we shall also install Docker Compose. Compose because we're going to run two containers. We shall run SonarQube container, and we shall run the PostgreSQL container, because that's going to be that's going to be the backend to our SonarQube. That'll be a backend database to SonarQube. Okay, so it's still upgrading. It's quite busy. Where you can see what's been upgraded. Yes. So as I said, we need to do this so that everything else runs properly. So once the upgrade is done, then we can go ahead and install Docker. Oh, this is, let me just clear this. This is just telling me I need to update the kernel. Let's just okay that for now. I'll do that later. Let me get rid of this. Hold on, please. Now, okay. Let me okay that again. Yeah, okay, that's gone. Okay, now, so we've updated, we've upgraded. Now let's clear this and let's install Docker. So to apt install docker.io -y. -y option is to prevent, prevent the prompt of yes or no. So there we go again. Now Docker has been installed. Once it finishes, we shall start it and enable it. The start will get it running, and enable will ensure that if we stop and start an instance, it will boot and begin to run. So let's start Docker. Sudo systemctl start. Yes. Docker. Yes. Now let's enable it. So the systemctl enable Docker. Let's enable it. Okay. And then after this, we shall check to see if it's been installed properly by checking the version. So let's do docker -- version. That command should give us the Docker version if Docker is installed successfully. So docker minus hyphen version, and yes, that's a Docker version there, 24.0.5 on our Ubuntu build. Yes, so that is okay. So Docker has been successful. Next, we shall grab a command. We shall call the command from GitHub to install Docker Compose. We need this, as I said, because we're going to run a multi-container. We're running 2 containers, not just one. Okay, so let's run this. This is going to install Docker Compose, and then we shall give it an execute permission, so we can execute, we can run commands on it. So yes, let's grab that. So sudo chmod, okay, plus X means give it execute permission. Now this URL, yeah, that's okay. We've done that. That's fine. Okay. So the next thing now is that we're going to create a Docker Compose, docker/compose.yaml file. I've already got it here already. It contains the configuration that we shall run to create our containers. It's a YAML file. So what that is, I will create the file first and then paste the configuration code into it. So I'll use the nano editor which comes with the Ubuntu package. So I'll do sudo nano, then docker/compose.yaml. That will open up. Okay, now here we can see the code that will run, that we shall use to create, which we shall paste into our YAML file, and which we shall use Docker Compose to run. So let's do that. Sudo nano, open a nano editor. No, sudo, sorry, nano docker-compose.yaml. Can be any name really, but I just use this because I like to use names. Okay, now so let us paste the configuration for our Docker Compose file. There it is. So now you can see it's version 3. The Compose. You can see the services. We have one service. One is SonarQube, and one is Postgres. That's the front and the back end, and the images we need to pull are there. We need the image for SonarQube latest and Postgres latest. So this will be pulled from Docker Hub. And also environment, we can see the environment variables, the password and usernames, which will be used for these containers when they're created. And also you can see the network, SonarNet, for both, so they can talk to each other. We've created a network, and we've assigned this network to both containers so that they can talk to each other. They will be on the same network, and they can see each other and connect each other. Okay, so that's all we need for this. We shall save this, and we shall now run the Docker Compose command to build our containers. Okay, so that's done, saved. So the command to run Docker Compose is Docker Compose is up. So go sudo Docker Compose up. That just means, you pull and run. It'll pull and then run. So yeah, that's a sudo Compose up. There it will pull the SonarQube and Postgres images and start both services in the background. So that command will execute, the code, the configuration we have in the Docker compose.yaml file we created earlier. So sudo docker compose up. Yes, and that's all we need. And we should, yes, -z means in the background. That is right. So now you can see it's pulling and the Postgres and SonarQube. It's pulling the images down. Once the pull is to run and start to create the containers. So it's still pulling. Okay, now it's running. The network has been created. It's creating the Ubuntu, the Postgres, and the SonarQube started. So now it has created the network and it started both the Postgres container and the SonarQube container. Brilliant. So we have both containers and the network running. That's amazing. So now we can go to our browser. Excuse me. We can go to a browser and try to access our SonarQube from the servers and from the server's public IP address and the SonarQube port. Okay. Yes. So let's go there. We need to get a public IP address again of our instance, the EC2 server, the SonarQube server. Same thing now. Let's go there and get the public IP address. Okay. Hold on. Okay, there. Copy that. And we shall head for our browser. So it'll be the public IP address colon the port number, and we shall be able to access our container if it was successfully provisioned. So we use 1990. Let's go port and go. Now it can be reached. Like I said, I knew that would happen because SonarQube's port is 9000, not 1990. So we have intentionally misconfigured the port just to show the firewall, just to show the importance of getting that. So it has allowed it to go in, but because of SonarQube's port is 9000, it has refused the connection. Our firewall has refused the connection. So we need to go back into our instance, go to the security group, firewall settings, and we need to edit with the correct port. Okay. So now let us go back. We need to access our security group for our instance. Hold on. Yes. Where is the security group? Down there. Okay, let's go to the security tab. Yes, security tab. And then you can see that's port 1990. It needs to be port 9000, not 1990. Okay, so let's click on this, access the security group. We need to edit the inbound rules. Let's click on the edit there. Yes. And now we can change the 1990 to 9000. That's 9000. We should change and then save this. And then we should be able to hit our SonarQube server from the browser. So let's save that. Okay. Once again, let's grab the public IP address. And this time let's use port 9000, and we should be able to access our SonarQube server on the web browser. Okay, in the web browser. So let's go paste that there, and now colon 9000, and now hold your breath. This should be okay if everything was done correctly. Yes, there we are. It's loading. So now we have successfully launched SonarQube in a container, and okay, let's log in with the default credentials, admin. When you log in, it will prompt you to change that in something more secure. So let me take this off. Okay, so now we need to change the password. Makes it more secure. So I will do that now. Yes. Okay. Yes, I'll change the password, and then when we update this, we shall be inside our SonarQube. Okay, yes, that we're in SonarQube, and that's all we had to do today. We have successfully deployed SonarQube on our EC2 instance. I hope you enjoyed this. I did. That we have deployed it as a container in the AWS cloud. So, ladies and gentlemen, that's it all for today. You have learned how to install, configure, and deploy SonarQube on an EC2 server. You also learned how to expose it and access our server via the internet browser. So thank you very much for watching. Please don't forget to subscribe, like, and share. And I'll see you again soon with another interesting tutorial. My name is Dilly, DevOps Uncut. Thank you.